For today's assignment, we are working on free fall calculations. Free fall is where gravity is the only force acting on it, ignoring air resistance, which can be a pretty big force if you free fall for a long enough period. But we're going to ignore it for these problems. So if you throw something up and it comes back down, the velocity is up and then the velocity is down. The velocity can be up or the velocity can be down. The acceleration from gravity is always down. Gravity is always down. So if you throw something up, it's going to be slowing down. And then it starts to speed up again. So if it's moving upward, this is what our little dot diagrams would look like. If it's moving downward, this is what our little dot diagrams would look like. But if it's moving down, then the velocity is down. If it's moving upward, the velocity is up. But acceleration is always down. Always. So a lot of these problems you're going to be given this little pattern that looks like this, where you have little dots that represent the object, the projectile, the baseball, the golf ball that we threw into the air. And so you have to remember that the top is always 0, and then there's 1 second in between each of those. So it might be beneficial just to sort of draw one of these permanently on a piece of paper, and therefore you can use it as a tool to answer a lot of the different questions. Now it may not be this many dots, you may only need this many, so these numbers would be a little bit different. If it's 0 right here, and that means this is a second and this is a second. That means it was 10 meters per second and then 20 meters per second. And so it left your hand at 20 meters per second, and this was 1 second and then 2 seconds, 3 seconds, and 4 seconds. It could be like the diagram on the left, where it left your hand at 40 and it took 1, 2, 3, 4 to get to the top. 1, 2, 3, 4 to get back. But if you just draw one of these, doesn't have to be, you don't really have to have the dots at changing distances apart. Just draw something like that and then think through the question. And then you're going to have another series where they're going to give you this right here, and you're going to have to read carefully, and they're going to tell you that this is the speed after 3 seconds, or after 5 seconds, or after 2 seconds, or after 4 seconds, and they will tell you if the ball is moving upward or down. So what they're doing is they're forcing you to calculate the velocity of the ball when it left your hand. So if this is 20 meters per second and the ball was moving up, and it's after 3 seconds, the ball's been moving up for 3 seconds, then you need to be able to calculate that velocity. And so you're just going to draw, you can do it on your fingers, or you can just have this permanently in front of you, or draw a bunch of them. So if this were the velocity after 3 seconds, and the ball was moving down, well, we know that the top is 10, this is 20. So if it was after 3 seconds, this is 1 second, 2 seconds, 3. So this was the initial velocity. That's really not a good example, because after 3 seconds, typically the ball goes up and comes back to where it started from. But I think you still get the idea. So you have to be able to use this to determine the initial velocity. Then you have to answer questions about where the ball would be after so many seconds. How many seconds would it be required to be moving 40 meters per second down, 20 meters per second up, and so forth? But you're going to want to use this little diagram right here, something like that.